Okay, so for question 1, what they're asking you to make is a 4-bit counter. So we did a 2-bit counter in class, the module 4 counter with reset, this one. So what that would look like in the crazy full diagram is this, where you have 1, 2, 3, 4 bits of output, and then 4 bits of state, which are these D flip-flops and the clock and all the reset. So in Verilog, you can actually make that easier, and you can just say reset goes in and the clock goes in. You can keep all your state bits as one bus, which I'll show you how to do that in a second. And you can have all your output as one bus as well. Instead of saying I have this x3, x2, x1, x0, you can just say output and the binary value. So that'll be a 4-bit binary value, like, I don't know, 0, 1, 0, 0. And how this will work, the output will just go 0, 0, 0, 0, 0, 0, 0, 1, etc. And it'll just keep counting up. And if you ever get a clock input, then it will reset to 0 at any point. So here's how we're going to do that. We'll start out by saying what will be our state. So we can actually just keep our state all in one thing, and we'll set that as a register. So I'll say 4-bit bus register. Oh, sorry, I'm trying to type with one hand. All right, 4-bit bus register called state. We'll set that to, wow, this is not going good. All right, call it state. I'm gonna set that to 16. I'll tell you about that in a second as to why later, but focus on this part at first. So what we have here is a 4-bit register. So that's like an array from 0 to 3 containing binary bit values. So what that really is a 4-bit value. And I'm starting it at 1111. It's for some reason is not 0 index. So I would think of that as 15, but you write 16. And the logic will come by and we'll explain why in a second as to why I started at 16. So I will call the count to be equal to the state. So basically I'm just counting how many clock pulses I have and putting that right to output. So that's the state. So I will say I have up here output count is already a 3-bit bus, or a 4-bit bus rather. I will say assign count equals state. So what this will do is this register is our state register, and every time that changes, the count will be updated to that. All right, so now here comes the logic bit. I'm going to say, 1 second, I kind of forget how to do this. Okay, always pause edge of the clock. So every time the clock is high, or whenever the clock is 1, or whenever the clock is hot, however you want to call that. First, I want to make sure that if the reset value is set to 1, then the output will just be 0. Oh yeah. So I can't actually set the output directly. You have to use the state, because the state is a register and the output is a wire. You can think of the wire as not being able to be changed, so you have to like indirectly change it by changing the register that's equal to it. So I will say if reset is 1, then state equals 0. So something to notice that will crash your program is that this less than equals for a register is actually the same as equals. So writing state less than equals 0 is the same thing as saying state equals 0. So if reset equals 1, state equals 0, and I'll just try to make this look a little more familiar with the indents and stuff. Else, you can use else. You didn't write about else, but you can use else. Else state equals, remember this is equals, state plus 1. Okay. So what is going on here is I am assigning a 4-bit register to be my state counter. So instead of having all these 4D flip-flops, I'm just having one state register, 4 bits long. To make it 4 bits long, you go 3:0. I'm starting it at 16. And I'm saying that the output will be equal to the state. So the first thing that's going to happen is the clock will be positive. It'll go to 1. Clock will go to 1. It will check if my reset is equal to 1. If it's not, then state will equal state plus 1. So here what's going to happen is, because I started at 16 and I added 1 to 16 when my clock went positive, my first output is going to be 0 because this is going to go, this is going to overflow because it's 4 bits, and when I add 1 to that 4 bits, it'll go back to 0, so my first output will be 0. And then you can imagine the clock pulsing in, going 1, 1, 1, 1, and every time that happens, I will have state equals state plus 1. My output count is equal to my state. And then if someone ever puts reset equal to 1, my state will equal 0. So let's just make sure this works. I'm going to run that. Oh, I actually did forget something. Okay, so at the end of this always block, you need to write end. Oh, and I also missed a semicolon here. Good old-fashioned debugging right there. So let's try this now. Great, so test pass. And question 2 is going to be the same, except you're going to throw in another else statement where you check if the reverse input line is equal to 1. So let me know how that works for you guys, and if you have any other questions.